To show the range and the rank of the linear transformation defined by these two matrices, we need to first, for the range, we need to come up with the reduced row echelon form of these two matrices, and then we're going to locate the pivot columns or the columns with leading ones, and on our initial matrix, we're going to pick those columns to be part of the basis of the range. The rank, on the other hand, will automatically tell us or shows the dimension of the basis of the range. So let's start with this matrix here and come up with this reduced row echelon form. To do that, we could always multiply row 1 by 1/5 so that this 5 here will be equal to 1. But of course, you'll be dealing fractions here later that for some of us have problems. So instead of looking that, let's try to, let me copy it here first, 1, 1, 1, 1. We are going to interchange row 1 and row 2. So we have here 1, 1, 5, -3, 1, and then 1. By the way, before we continue, we also notice here that we have two rows of the same entries. We have 1, 1, and 1, 1. This means that we are expecting here rows of zeros, as this would be equal to, or one of which should be equal to 0, 0 once we are going to manipulate it. Talking about with this process here, as we're going to make this zeros. So first, -5 times row 1 plus row 2 for a new row 2. And then -1 times row 1 plus row 3 for a new row 3. Here, you will have 1, 1. Then -5 times 1 is -5 plus 5, 0. -5 times 1 is -5 plus -3, -8. Then you have -1 times 1 is -1 plus 1, 0. -1 times 1, -1 plus 1, 0. Notice that the third row is already a row of zeros, as mentioned earlier. Next, let's make the 0 by multiplying -1/8 to row 2. I mean, not 0, 1, by the way, leading 1. So you have your 1, 1, 0, that's 1, 0, and 0. There should be a last step here to come up with the reduced row echelon form, because this is still on the row echelon form. Let's make this 0, because the reduced row echelon form is very specific that if a row contains a leading 1, we have here 1 here, all other entries on that same column would be 0. So we have here negative of row 2 plus row 1 for a new row 1. Then we'll have this final form, 0, 0, this is 0, 1. -1 times 0 will not change anything, so this is 1. -1 times 1 is -1 plus 1, 0. This is the reduced row echelon form of our first matrix, and we can see here that both rows contain leading 1. What does this mean? Going back to our initial matrix, with represented by these two columns, as we have here these two columns here as well. These two columns now are part of our column space. The column space is equal to the basis of the range of T. In short, our basis for range here is equal to a set containing those two columns. You have 5, 1, 1, and then you have, I believe it's -3. Yeah. In our initial matrix, you will have, sorry, -3, 1, and then 1. Or you could always come up with this form. You have 5, 1, 1, sorry, and then -3, 1, and then 1. This is our basis for the range of the first matrix. Now, the rank of T for this matrix is equal to the dimension of the basis of your range. In short, we simply look at the dimension of this basis, or either this basis as well. That would mean the rank of T, since our basis contains two vectors or two elements, the rank is 2. Okay, that's it how we solve the rank. Let's duplicate the process for our second matrix here. Again, let's come up with the reduced row echelon form of this. But noticeably, we know that the middle row is already zeros. for this to become a reduced row echelon form, the row of zeros must be placed on the bottom portion. You have 4, 1, so simply interchange row 2 and row 3. You have 2, negative 3, so that the row of zeros will be placed here. Next, let's make this a leading 1 by multiplying 1/4 to the entries on row 1. So we have here the next. This is 1. This is now 1/4. 2, negative 3, 0, and 0. To make this 0, we will multiply negative 2 to row 1 plus row 2. Okay, so we have here 1, 1/4. When you multiply negative 2 to 1, you will get negative 2 plus 2, 0. Negative 2 times 1/4 is equal to negative 2/4, or negative 1/2. Okay, negative 1/2 plus negative 3, which is negative 6/2. You have negative 7. Oh, yeah. Negative 2 times 1/4 is negative 2/4, so negative 1/2. This is negative 6/2. So you have negative 7/2. 0, 0. No need to worry about the fraction because we're going to make this a leading 1. We'll have here negative 2/7 of row 2 for a new row 2. So you have here 1, still 1/4, 0. The negative 7/2 will become 1, 0, 0. And finally, let's make this 0 by multiplying negative 1/4 to row 2, plus row 1 for the new row 1. Then, I have this form, 0, 0, 0, 1. Then, this is still 1. Negative 1/4 times 1 is negative 1/4 plus this 0. So this is now the reduced row echelon form. Okay, so what we could do right now is to form the basis for the range of T, which should contain the column space of our initial vector, since these two columns here has or contains leading 1s. So in our original, we'll have this, initial matrix 4, 0, 2, 1, 0, negative 3. So you have 4, 0, 2, and then I believe it's negative 1. I know, it's positive 1. Pardon. Positive 1, 0, negative 3. Or you can use this 4, 0, 2, and then 1, 0, negative 3. Alright, now the rank of T is now equal to the dimension of the range. We have 2 elements here, so the rank of T for the second matrix is also 2. So this is how we show the range, or the basis of the range and the rank of linear transformation defined by these matrices, specifically 3 by 2 matrices. Thank you very much for watching.